Okay, today we're going to talk about lesson 4, which is polar coordinates, and we're going to be able to convert points and equations from polar to rectangular and back and forth. Now some of this is going to seem like what we've been doing all along, and some of it's going to seem kind of new to you. If you see the word pole, it's just a point at the origin. So I drew the x-axis, and there's my origin. I could also draw the y part here. And so what I have here is I have a ray. It goes from the polar axis, and however many angle, degrees or radians that I go, and this is the length of my ray. So you have a directed distance r and an angle theta, and this is how you would write it. Now it doesn't look much different than how you would write a point. The only way you're going to know is by knowing the context of the problem. So now what I have here is the point P. It has a directed distance of 2 and an angle of pi over 3, which, if you don't know what that is, I'll write it. It's 2 and 60 degrees. So what I'm going to do is I'm going to draw my axes, and I'm going to go 60 degrees, or pi over 3, and I have a distance. The directed distance of this ray is 2. Now here's another point, Q. And in point Q, I have a -1, and my angle is 3 pi over 4. Now this one's a little bit different. You always do the angle first. Now remember, this is 135 degrees. So I'm going to take my rectangular coordinate, and I'm going to go 135 degrees, or 3 pi over 4. Now notice I have a -1. All my directed distances are positive, so I know that I'm around in here, and this negative tells me it's in the opposite direction, and it has a length of 1. That's different than what you're used to seeing. Look at this one. This is the coordinate 3 and -45 degrees. So what I'm going to do here is I'm going to draw my axes. I'm going to go -45 degrees, and then I have a length of 3. -45 degrees and a length of 3. Okay, in this example too, what we have here is we want to find the point P. It has this polar coordinate, a length of 3 at pi over 3 radians, and we're going to find only 4 polar coordinates for that point. The first one is pretty obvious. So I take the pi over 3, which is 60 degrees, and I have a distance here of 3. That's one of them. But I could also go in this direction. And when I go in this direction, it's a negative angle, still a positive 3. So I have 3 pi over 3. I'm going to have another positive. I'm going in the correct direction. So that's still a positive 3, but now I have a negative angle. And the negative angle is -5 pi over 3. Remember, it's 2 pi minus a third. So that gives me 2 of my coordinates. Okay, I could get 2 more. Let's take this and go in the opposite direction. That means I'm going to have a -3. And now I want to know what this angle is. Well, if this is pi over 3, which by the way is 60, and from here to here is a 180, then what I'm looking at is 180 minus 60, which is 120. So a -2 pi over 3. Now I'm still going to go this direction, so I still have a -3, but now I'm going to start here, and I'm going to go all the way this way. So now it's 180 plus 60, or 240 degrees, or 4 pi over 3. Those are the 4 coordinates that I can have to represent that point. Now keep in mind, there are an infinite number. I could keep going round and round in a counterclockwise direction, or I can go round and round in the clockwise direction. But all I'm looking for right now is 4 polar coordinates. In the previous example, I only found 4 polar coordinates, but if I want to find any polar coordinate, this is the form that it has. This is the directed ray, the resultant, the distance, if you want to call it, the magnitude. Here's your angle. And this would be, we could call it 2n pi or 2 pi k. N it represents an integer. So I've got several that I can do that way. Or I could have a negative directed ray, and then I'm going to actually have whatever my angle is plus 2n plus 1. My n in both of these cases is an integer. So I can have it 2 times 1, 2 times 2, 2 times 3, 2 times -7. And that will show either I go clockwise or counterclockwise around the circle. Okay, we've been looking at trig, and we've been finding equations, and we've been looking at things like right triangles. And when I draw a right triangle, I have, for example, this is my angle theta. Here's x, here's y. And if I want to know what this r is, it's the Pythagorean theorem, x squared plus y squared square root. Now, if I want to know how to find the angle and all I was given was the x and y, then my angle is just the inverse tangent of y over x. Now, those are the things that we've been doing, and that's how we're going to convert polar to rectangular and back and forth. Again, I don't memorize these equations that I'm going to show you. I just know how to draw a right triangle, and I know the Pythagorean theorem, and I know SOHCAHTOA. So here's what we've got. X equals r cosine theta. Well, how in the world did I get that? Well, let's find out. I'm going to take the cosine of theta, and it's adjacent over hypotenuse. Now you can see it. And I'm going to solve for x. R cosine theta equals x. I'm also going to take sine theta, and I am going to say that it's y over r, and I'm going to solve for y, so this is r sine theta, just like we've been doing when we did vectors components, just like we were doing when we do triangular trig. And if I look at this, so there's my x, there's my y. If I want to find my r squared equals x squared plus y squared. That comes from the Pythagorean identity. And if I look at my angle, the tangent of theta equals y over x, which again comes from SOHCAHTOA. And so here is my drawing, and here are my equations. Please don't memorize them because we've already done triangular trig and we're just using those same facts. Okay, in example 3, we need to convert from a polar to a rectangular. First thing I'm going to do is draw my triangle in the correct quadrant. So I take my picture, or my coordinates. I go 5 pi over 6. Now if you don't like radians, that's the same thing as saying 3 and 150 degrees. Same exact thing. So I went 150 degrees, and it has a length of 3. Keep in mind it's not to scale. And we need to find the x and the y. Well, I'll write this better over here. There's 3. Here's my right triangle. Can I find my x and can I find my y? This angle here is 180 minus 150. So here's a 30-degree angle. And I know that x is going to be 3 times the cosine of 30. And because I went to the left, it's negative. And my y is going to be 3 times the sine of 30 because it's going up. And when I do that, I am going to get the following. I'm going to get negative 2.60 and 1.5. Now think about it. I went to the left and I went up. Do these numbers make sense? Left is negative, up is positive. So it looks like those make sense. The next one we're going to do is this point. So I'm going to draw it. Now it's a negative angle. 180, 200. And then I have a positive distance of 2. So that's 200 degrees in the clockwise direction. Well, 200 minus 180 means that this reference angle is 20 degrees. I need my y and I need my x. Well, x is going to be 2 times the cosine of 20. Because it went to the left, that's negative. Y is going up, so it's positive 2 times the sine of 20. Punch that into my calculator and I get negative 1.88 and I get 0.68. Okay, in example 4 we're going to convert rectangular to polar. Now here they gave us the rectangular coordinates and they want us to find 2 polar. Draw your picture. I went to the left 1 and I went up 1. So negative 1, 1. I need to know this r. Well, to find the r, it's going to be negative 1 squared plus 1 squared square root. And I get the square root of 2. To find my angle, I'm going to take the inverse tangent. Why? Because I have opposite over adjacent. The inverse tangent of 1 over negative 1, I'm going to get in my calculator a negative 45. What that means is the calculator gave us this angle, which is the same as this angle. Since I have to come from standard position, I'm going to call it 135 degrees. So my polar coordinate is now square root of 2, 135 degrees. Now that's one of them. I need another one. Well, if I want to keep this positive, I could always come around here and I could say that it's square root of 2 and now it's 180 plus 45, which is 225, and because I went in the negative direction, it is negative. Now these are just 2 examples. You have an infinite number of examples depending on how many times you want to go around and around and around. Part B tells us that the point is negative 3, 0. So I'm going to go 1, 2, 3, and 0. There's that point. Here is my r, and this is my theta. So I really don't have to do a whole lot. I could just say r equals 3 and theta is 180 degrees. But if you don't believe that, what you could do is realize that your r is negative 3 squared and there's no vertical and you get 3. And if you were looking at your angle, there's no angle. It just went 180 degrees. And so now if I'm looking at one of them, I'm going to write my polar coordinate. I'm going to write it as 3, 180 degrees. And if I want to, I could go 3 and negative 180, or let's try a negative one. Let's go over in this direction. Negative 3, so if I went 180 degrees and I have a negative, it's over here, 0. I might be able to see it better this way. I go 180 degrees and then I went a negative, which means I'm going to go backwards. That's how that works out, okay?